Hello, my name is Adam. In this video, we are going to learn how to recreate the game Space Invaders in Unity. Space Invaders was developed in 1978 and was the first fixed shooter that set the template for the shoot 'em up genre. The goal is to defeat wave after wave of descending aliens with a horizontally moving laser to earn as many points as possible. This is the fourth video in my series of recreating classic arcade games in Unity. So far, we have done Snake, Pong, Asteroids, and now Space Invaders. Subscribe to the channel to be notified whenever I release a new tutorial. Let's go ahead and jump right in. Let's begin by creating a new project using the Unity Hub. In the top right, we can select the blue drop-down to choose the specific version of Unity we want to use. So in this case, I'm going to be using Unity 2020.2. From here, let's select the 2D template since this will be a 2D game. And I'm going to call this Space Invaders and choose wherever you would like to save your project and go ahead and click the create button. From here, it might take a couple minutes to initialize, so give it a second and we'll pick it up as soon as it finishes. First, we're going to want to set up our entire scene. This includes creating various game objects and adding some components to those game objects so we can actually start scripting them. But first, I'm actually going to pull in a bunch of sprites that I have already created, and we'll use all of these sprites throughout our entire project. Let me go ahead and create a new folder, and I will call this sprites. Let me drag in the sprites that I already have created. You can use all of these sprites alongside me. They will all be available to download through GitHub with the rest of the project as well. There's a link in the description of the video that contains all of these. But also, if you want, feel free to create your own sprites. First, we're going to want to change a few settings on some of these sprites, or all of these sprites actually. So let's select all of them, and let's change first pixels per unit from 100 to 16. 100 is going to be too large. I designed all of these sprites around 16 pixels per unit. Next, we're going to want to change our filter mode to point. And finally, we can change our max size to 64 and our compression to none. And this will make sure the pixel graphics actually shine through and they're not getting filtered or anything like that. And that's it for our sprites. Now we can continue setting up the rest of our scene. Unity by default provides us our sample scene here. I'm going to actually just rename this to Space Invaders and reload the scene. In the left here is our hierarchy where we can see all of the game objects that exist in this scene. And once again, by default, Unity provides us one game object, which is our camera. Since this already exists, this will be the first object we change. Really, all I want to change is the color to black. And I'm also going to change the size here from 5 to around 15. What that's going to do is effectively zoom out. So for example, let me just throw a sprite into our scene. So you can see a little invader there. And at the size of 5, it's very large. It's too large for our entire scene. So by setting our camera to 15, we're effectively zooming out and it's giving us more space to work with. So let me go ahead and delete that invader. The other thing I want to do right now is actually just change our resolution for the game. So here in the dropdown, we can go to, we can click the plus button to add a new one, and we can set a custom resolution. I'm just using a resolution of 1:1. So you could type in aspect ratio, you can say 1:1. I already have it created here, so I'll select that and this will make it a square. I also can uncheck the low resolution aspect ratio here to make it fill the entire space. And that looks a lot better. Next, let's add our player to the scene. So if we go to our sprites folder, we have our player sprite here, and I can drag this directly into the hierarchy for it to show up in our scene. This will automatically create a game object, add a sprite renderer component to that game object, and assign the correct sprite. From here, I want to change the color from white to green. Looks good, and let's move it towards the bottom of the screen. Let's say -13, looks good. There's a little bit of space between the bottom edge and where the player is. Now I also want to add one more component to this object, which is going to be our box collider 2D here. The non-2D is intended for 3D games, so since this is a 2D game, we will choose box collider 2D. And I want to change one property, which is to set this to be a trigger. All of our objects in this entire game will be marked as trigger colliders to simplify our code later on. Also, you'll notice that the size is automatically set to fit this sprite exactly. If I change the size here, you can see the green outline, which indicates the area of this collider. And of course, as I mentioned, by default, it automatically sizes it to our sprite as long as you add your box collider after you have already added your sprite. So that's exactly what we want. We'll keep that how it is. Next, let's add our bunkers to our scene as well. So the process will look exactly the same as what we did for our player. So let's find our bunker sprite and let's drag that into our hierarchy. Let's change the color from white to green, the same green that our player is. And let's position this towards the bottom of the screen. So let's say -10 looks good. There's a little bit of space between the player and the bunker. Let's go ahead and add our box collider as well. Let's mark that as a trigger. As I mentioned, every object will be marked as a trigger. And you can see the size has been set automatically for us to match the size of our sprite. And that will be it for our bunker, but we actually need 4 of these. So let's go ahead and duplicate these. You can right click and select duplicate, and we have 4 of them, and let's position them now. So let's say there's maybe 6 units of space in between each one. So we can do -3 and then -9, and we'll do +3, and then we'll do +9 to space them out pretty evenly. And that looks good. So there's our 4 bunkers. I'm just going to rename them so they all have the exact same name as bunker. And that's it. Next, let's add our mystery ship object to the scene. So just like the others, let's find our mystery ship sprite. Let's drag it into the hierarchy. Let's change the color to red for this one. And let's position it towards the top of the screen. And I will just make this pretty much the exact opposite of the player. Player was -13, so I'll make this one +13. Let's also add our box collider component, so box collider 2D. Let's mark it as a trigger, and the size is already set for us. So that's all we need to do for our mystery ship. Finally, we want to create 2 invisible boundaries that will surround our scene. This will just be a simple game object with a box collider component. So let's go ahead and right click in our hierarchy, select create empty. Let's reset our transform here so all the values are at their defaults. And let's add our box collider 2D. Let's mark this as a trigger. I will call this boundary as well. Let's switch over to our scene view so we can actually see this. You can see right in the middle is our box collider. Let's scale this so it is exactly the same width as our scene. So it looks like 30 is good. And let's position it at the very top, right on the edge of our scene. Doesn't have to be perfect, but I will go ahead and round this, let's say 15.5. And let's duplicate this. And let's move this now to the bottom as well. So -15.5, that looks good. So what these 2 boundaries are going to do is catch any laser shots or missiles from the player and invaders. So for example, when the player shoots a laser, let's say the player completely misses, we don't want that laser to go off the screen and out of bounds and then just move on forever. So this collider will make sure that that laser still gets destroyed even when you miss. And then same thing for the missiles that are shot by our invaders going downwards. Next, we can start forming our grid of invaders. If we wanted to, we could just manually place each individual invader in our scene, but I would prefer to write a script that will do it for us, and then it'll also give us more control over customizing that grid if we want maybe a different amount of rows or columns. But before we can write that script, we need to set up a couple prefabs. So let's go ahead and do that. Let's create a new empty game object in our scene. So we can right click on our hierarchy, select create empty. I'm going to reset this game object here, or the transform I mean. So all the values get set to their defaults. I'm going to call this Invader. Actually, I'm going to call this Invader Base, and I'll explain why in a minute. And let's add a couple components we're going to need. So one's a sprite renderer, and we're also going to want to add our box collider 2D. Now, in this case, we don't have a sprite yet because there's multiple sprites for us to choose from. And we're going to utilize something called prefab variants that allow us to set a different sprite but keep the rest of the properties and components the same. So, given this game object here, we can create our base prefab. So let me create a new folder called prefabs. And all we need to do to create a prefab is drag this into our folder down here. So now we have a prefab called Invader Base. A prefab is a custom type of asset that we can reutilize throughout our entire project. And it'll also allow us to instantiate new instances of this game object through our script later on. So that's just our base prefab, but we want to create a variant of this that has a specific invader sprite attached to it, as well as the size of our collider and so on. So for example, maybe by default, this is just 1, but this will get overridden based on the sprite that gets set. So let's say here we want to assign our specific invader this time. So let's say Invader 1, we can drag that into our sprite there. We can see it show up in the scene. And let's reset our box collider 2D so the size gets updated. In this case, the size actually was fine, but for some of our other sprites, the size will be slightly different. So now that we've made a couple changes here, we can revert that. You can see on the left here, anytime you make a change to something, you'll see a little blue to indicate that property has been changed compared to what the prefab is currently set to. So all that's been changed on this particular object is our sprite here. Now, if we drag this again into our project, our project folder, we can create a different prefab that's a variant of the base. Let me first rename this. I'm going to call this one Invader 1. So I'll drag this in, and it's going to ask us, would you like to create a new original prefab or a variant of the prefab that I'm already using? And we're going to create a variant. And so now we have Invader 01 variant. I'm just going to get rid of the variant there and just have Invader 01. And notice how we can actually see the sprite show up there too. Let's do this again. Now this time, let's delete that. Let's start with our base once again. And let's assign a different sprite here. So let's assign number 2. And let's reset our box collider to see if the size changed. So yeah, in this case, the size actually did change. Let's revert our trigger. We want to keep that how it was. But our size and our sprite are the differences in this particular game object. So let's do this once again. Let's drag this into our project folder. Let's create a prefab variant. I forgot to rename it, but that's okay. We can rename it right here. So I'll just call this Invader 2. It's going to actually rename the game object for us as well. And one final time, let's do this for our third one. And so we start with our base. So I drag that into our scene. And now I'm going to assign the correct sprite. So let's get the third one here. And you might be wondering why there is actually 6 different sprites. Later on, we're going to animate these invaders. So there's really 2 different sprites per invader. So for now, I'm just selecting the first one for each. But so Invader 3, let's reset our box collider so the size gets automatically updated to fit that particular sprite. Let's revert our isTrigger so that stays the same. And once again, you can see the only changes on this object are our sprite and our size. And we can drag this in one final time, create a prefab variant. Let's name this one Invader 03. So now we have our different invaders, which later on we can write a script to lay them out in a grid. I'm going to get rid of the base there from our scene. And at any point, I could drag in different invaders into my scene, or if we want to write a script to do it, we can do that as well. Let's write our first script to animate our invader sprites. So let's go ahead and first create a new folder to contain all of our scripts. Let's go ahead and open that up, right click, create C# script, and I'm just going to call this Invader. Let's open this up. And Unity by default provides a class that inherits from mono behavior. There's also going to be a couple of functions that are just very commonly used, but I actually like to kind of just delete everything and start from scratch. It's just my preference. So to animate our invader sprites, we're going to need to keep track of an array of sprites that we want to cycle between. And so let's create a variable for that. I'm just going to call this animation sprites. So this is an array of sprites. It's public, so we can actually change it in the editor, which we'll be able to see in a minute. We're also going to want a variable for the animation time, which is essentially how often does it cycle to the next sprite. And then we're going to need a reference to our sprite renderer so we can actually change which sprite is currently being rendered. So let's just call it sprite renderer. And we also need one other variable to keep track of which, sprite we're currently using, which is just going to be an index within our array. So this will be an integer. And we'll just call this animation frame. Okay, so now first let's establish our reference here to our sprite renderer. So we'll do this inside our awake function, which will be the very first function that gets called for the life cycle of this script. And Unity will call this for us automatically. And so we can assign our sprite renderer by saying get component. And then we specify the type of component we want to get. And that's it. And so what this is going to do is it's going to look on the same game object that our invader script is attached to. It's going to look for the component that we specified, which in this case is sprite renderer. And when our script starts executing, so the start gets called the very first frame this script is enabled on an active game object. And so on that very first frame, we want to start our animation loop, basically. And we can do something called invoke repeating. So invoke is allowing us to invoke a method after some amount of seconds. And then repeating is that it's going to repeat that over and over and over again. So we need to provide a method to actually invoke. So let's actually create that first. And I'm just going to call this animate sprite. And so in our invoke repeating, we can reference that method here. And then we need to provide how often it's going to repeat this. And there's the initial time, like the initial first time this gets called, like how many seconds. And then from that point on, how many seconds every time after. And we're just going to use our single variable animation time for both of those. Okay, so once again, basically what this is going to do is it's going to call our animate sprite every, X amount of seconds, whatever is provided here. And let's say by default, this has a time of 1 second. We can change this in the editor because we've marked it as public, but 1 second should be pretty sufficient. So within here, anytime we say animated sprite, we're basically going to update which frame we're on. So we're going to say animation frame ++ to increment it to the next one. And then we need to check to make sure that our current frame does not exceed however many sprites we actually have provided. If you're exceeding how many sprites you've provided, well, then we should loop back to the very beginning again. We can say if animation frame is greater than or equal to however many sprites we have, so .length, well then we will simply set that back. Oops, let me fix that. We will simply set that back to 0 to start over again. And then from here, all we need to do is update which sprite we're rendering. So we say sprite renderer.sprite equals animation sprites, and then we're going to get the element at the index here, which is our animation frame. And that should be it for animating our invaders. Let's go ahead and add our script to our Invader Prefabs here. And really all we need to do is add it to the base prefab, and it will automatically add that to the variants that we've created. So I have my base prefab selected. Let's drag our script into the empty space there. Here you can see by default, you know, there's 0 sprites being provided. Our animation time is 1. And now we can set the individual sprites on each of these variants. And notice once again, I only added the script to our base prefab, but because we created these as variants of the base prefab, these other prefabs also get that script. And so for each one of these, let's go ahead and assign our 2 sprites. Let's do for this one, we're going to do 1 and 2. If you are using the same sprites as me, once again, they're all available to download for free in GitHub with the rest of the project as well. If you're using your own sprites, then feel free to assign these, and you can have more than 2. You can have as many as you want, really. And then finally, our third one here. Oops, 2. Okay, that should be good. Let me double check. Yep, looks good. Okay, and just for the sake of testing this out, let me bring all of these into our scene here. Let me just spread them out so I can see them all. Let's go ahead and play our game real quick. And we should see these updating. Yep, so every second you can see the sprite kind of change to the next one, and then it starts over again. And there we go. So that's it. That's all we need to do for animating our sprites. Now that we've set up and animated our individual invaders, let's finally form our grid of invaders. So first, let's create a new script, and I'm going to just call this invaders, plural. And let's also create a game object to go along with that. So this will be an empty game object. We'll call it invaders. Let's reset the transform so it's at the origin, which is the middle of our screen. Let's add our script to that game object. And so this game object will act as a parent, which all the individual invaders will be attached to. Let's go ahead and edit our script here. And let's add a couple variables. So we're forming a grid, and a grid you can think of as rows and columns. So let's have 2 variables, rows and columns. So this is the number of rows and the number of columns. By default, Space Invaders has 5 rows and 11 columns, but feel free to set those to be whatever you'd want. We're making these public variables so we can change them in the editor if we want to. And we also want to have an array of prefabs that will correspond to each row within our grid. So each row instantiates a different prefab. So we can set up an array of invaders here, and we'll call this prefabs. And then finally, in our awake function, we can perform all of the actual logic. So let's start by just creating our 2D for loop, or our nested for loop to loop over each row and column. So we can say something like for int row equals 0. So it'll start at 0. Row is less than however many rows we have, and then row will get incremented. Then same exact thing for columns. We'll say col equals 0. Column is less than however many columns we have, and column plus plus. So pretty standard for loops there. And within here, we can basically just instantiate each one of our invaders. And then we need to provide a prefab that we want to clone from. So the prefab will just be whatever row we're currently in. So once again, this array of prefabs corresponds to each of the rows. So we can just say row. And then we can provide a second argument here, which is going to be the transform we want to parent this invader to, which is this transform, our invaders as a whole. And that's it. And we can even store the result of this into a variable here. So Let's go ahead and take a look at what this does. There's definitely more we still need to do, but let's run this. So we need to assign our prefabs here. So let's set the size to be 5 because there's 5 rows. Let's go ahead and drag in our different prefabs to these spots. And so element 0 will actually be the bottom row, and the last element will be the top row. Normally there's 2 of these at the bottom, and there's 2 of this middle one. And then the top row just has one row of those. Okay, let's run that one more time. So we can see all of our invaders here are stacked on top of each other. That's because we haven't yet set their positions, but you can see all of the invaders being cloned here. They even have the word clone in their name because we're instantiating them from the prefab, and they're all being parented to this game object here. And the reason for that is because we're eventually going to change the position of our invaders as a whole. And so instead of having to change the position of each one individually, all we'll have to do is change the position of the parent here. Okay, now let's actually do the math to set their positions. So we're going to need to know the position of the row, and then from the position of the row, we can offset that based on the column. So let's establish a variable here called row position. And I'm actually going to come back to this. I want to kind of just lay the outline of our code first, and then we'll actually assign a value to this. But after we instantiate our invader, we will set our position. So initially the position of our invader will be whatever the row position is. And then once we have our row position, we can offset that by whatever our column is. So the columns refer to the x-axis, and the rows refer to the y-axis. So for our column here, we're going to change the x, say plus equals, and then basically we just need to say whatever column we're currently on, and then multiply that by some amount of spacing. So let's say there's 1 unit of spacing. So let's say each individual invader is 1 unit. And then let's say there's an extra unit of spacing or padding in between the invaders. So for a total of 2 spacing, we can hard code that value. Now we could actually turn this into a variable so we can change it in the editor. But just for the sake of simplicity, I'm just going to hard code that. So column times spacing, and then finally we can set our invader's transform position to be that position. Okay, now we need to do our row position here. This one's going to be a little bit more involved, but initially here it's going to look the same. I mentioned earlier that the X or the columns refer to the X-axis and the rows refer to the Y-axis. So the Y here is the main thing we need to set. It's really the same thing. It's whatever row we're on times some amount of spacing once again. And so, what's the, we can say the size of each invader is 1 unit. And let's also say there's 1 unit of padding in this axis as well. So we'll just use 2 just like we did for that. And that's it really. There will be more we need to do to this, but let's just see what this looks like for now. So there's our grid of invaders. They're all being animated. Looks good. Now notice how as a whole, they are not centered correctly. So that's what we want to set our x-axis here for the row position. We kind of want to apply an offset so everything becomes centered. So let's say we have a variable here called centering. And our centering is basically we need to subtract half of the total size of our grid, right? So let's say the total size of our grid in the width would be our spacing 2 that we've specified times the total amount of columns minus 1. Just that column is minus 1. And then the same thing for the total height of our grid. It's whatever the spacing we specify, 2. And then the total amount of rows minus 1. So this gives us the total width and height of our grid. And then from here, our centering is just going to be subtracting half of that, because the center point should be, the center, it's halfway from halfway from each edge of our grid. So that's why it's half. So new vector 3, or this can actually be a vector 2. It only needs 2 axes. So width, or once again, we're supposed to subtract, so it should be negative width divided by 2, and then negative height divided by 2. So that's our centering, and then we just need to simply apply that to our row position. So our x here becomes centering.x, and then our y will become centering.y plus the position of the actual row. So that logic still remains. And that should be it. Let's go ahead and test it out. Okay, there we go. So our grid looks centered perfectly within our screen now. And we can even go to our scene view, and you can see the very middle invader. The very center invader is literally at our origin of our entire scene. So our grid is completely centered and everything. Now, normally our grid should start off a little bit higher, but that's where we can just simply change the position of our parent game object. And so for our parent game object, we can change it, and then it'll move them as a whole. Now I want to make sure this isn't running, so this value gets saved. So let's say it has a Y position of 7. Let's rerun it. 7 there. Oh, you know what? I made one mistake in our code. I made one mistake in that we want to set the local position, not the world position. Notice how I changed the parent game object here. I could set this to some really large number, but it doesn't do anything at all. And that's because we're setting the world position of each of our invaders. But if we set this to be local position, it will now be relative to our parent here. So let's try that again. Let me set this back to what the value I thought it should be, 7. Let's play it again. And notice how now they're spawning at the top. I could change this to, 2. It'll just be slightly above the center. But yeah, that value of 7 works well. They'll spawn near the top of the screen, and they'll slowly work their way down. So that looks good. Let's focus on making our invaders move now. Let's open up our invader script again, and let's continue expanding upon this. To get them to move, all we need to do is update this single transform for the parent object here, instead of having to update each individual invader. So we can do that inside of our update function. Update is called every single frame the game is running, and this is where you very commonly do things such as movement or input, or things like that. So here, to update our transform's position, our invader's position, we need to essentially know the direction they're moving, multiply that by speed, and that's really it. So let's add a variable for direction. And our direction will be a vector 3. And let's say initially they move to the right. And let's also add a variable for speed. And let's just set this to maybe 10 for now. We're going to end up changing this, but let's just throw that in for now. And so our position here, we can plus equal direction times speed. And we also want to multiply by time.delta time to account for frame rate. This will make sure our movement is consistent regardless of the frame rate of our game. And at the gist, that's it. But of course, there's going to be a lot more we need to do to this. But let's test it out. You can see they're moving to the right. It's definitely way too fast. And that's okay. I can change that to 1. And actually, I'll have to change it here in the editor. So let's set that to 1 for now. But the other thing we need to do is when it touches the edge of the screen, when any of the invaders hit the edge of the screen, it needs to flip the direction. So instead of going right, it should then go left, and then vice versa. It should continue to flip back and forth every time it hits the edge of the screen. So how can we do that? Well, we need a way to check each individual invader's position. So we can say for each transform, and then we can give this a name. Let's call it Invader. In this transform, so this is a way of looping through every child object or every child transform that's parented to this one. So for each invader in our transform, we can perform some logic. So we can check, has this invader touched the edge of the screen? If so, we will flip the direction of the entire thing. One thing we'll want to first do though is check that our invader has not been disabled. So later on in our game, when you shoot an invader with your laser, that invader will get deactivated. And so we don't want to check for any of this for any deactivated invaders. Right now, it's not going to matter, but later on it will. So for this, we can just say if invader.gameObject.active in hierarchy is a way of knowing whether this game object is active in the hierarchy. The hierarchy being, in the Unity editor, you can see your hierarchy on the left. So we should say if it's not active, then we can just continue on to the next one. So this will just jump to whatever the next one is in their transform. And then from here, we need to check the edge of the screen to see if the transform or the position of the invader hits the edge. So, and then we need to know, is it the right edge or the left edge? So first we should say if our direction is moving to the right, well, then we need to check the position of the invader on the right side of the screen. So if the position is greater than or equal to whatever that right edge is, then we know they've hit and we should have them flip direction. Now the question is, what is the value here? So there's a little bit of calculations we need to do, but luckily Unity provides the functions to do it for us. So let's go ahead and create some variables outside of our for each loop. And let's call one left edge. And what we're going to do is say camera.main viewport to world point. What this is going to do is translate some viewport coordinates into world space coordinates. So the viewport here is just for the viewport for our left edge is just simply going to be 0. And then the viewport coordinates for our right edge will be 1. Let me finish writing this first. So this is going to be 1 in the x-axis, which a shorthand way of writing that is to say vector3.right. And you can see if I hover over this, you can see the x-axis here is set to 1. So that's our left edge of the screen, and this is the right edge of our screen. So just kind of a simple way to get those world space coordinates using some of these transform functions that Unity provides to us. And so now we can say, okay, if the invader position is greater than or equal to our left or our right edge dot x, then we know we need to flip the direction. But really, we're going to actually do more than just flip the direction. We want to flip the direction, and we want to advance the invaders to the next row. So they're going to go down the screen as well. So maybe we have a new function called advance row. And in there, we can flip the direction. Direction.x times equals -1, which will negate it, or just, if it's positive, it'll go negative. If it's negative, it'll go positive. And then we want to move our invaders down. So let's take their current position. This how transform that position. And we can just simply update the Y here to be 1 unit less, which will move it to the next row. And then we can assign this back to our transform. And we'll call this inside our if statement. And then this should be if direction. Oh, this should be vector 3, not vector 2. And then same thing in our left, for our left edge. So if the direction is left and the invader position dot x is less than or equal to the left edge, well, then we'll go ahead and also advance row. Now, one small thing we should probably do here is add a little bit of padding between the edge and where the invader hits. So we can say right edge -1 and then left edge +1, just to give it a little bit of padding so it doesn't, we make sure our invaders don't clip off of the edge of the screen. And let's go ahead and try this out. I think that should be good. So we'll wait till they hit the edge of the screen and hopefully they should move down. Yep, they just moved down and they switched directions. So now they're going to the left. Let's see if they go back to the right in a moment here as well. And they do. Awesome. So that is working perfectly. Now, one thing we're going to do, not now, but later, is change the speed of our invaders based on how many invaders are currently alive. So normally in the game of Space Invaders, the less invaders that are alive, the faster they move. So in other words, they move pretty slow at first, but as the game progresses, they go faster and faster as you start killing them. But we will worry about that a little bit later. Next, let's shift our focus over to the player. So let's go ahead and handle player movement and shooting. Let's create our new script called player. Let's go ahead and drag that onto our player game object right away. And let's edit this script. So first, for movement, we're going to want a speed variable, of course. So let's add that. Say speed, maybe the default value is 5. And inside of our update function, we can change the position of our player based on that speed. But we need to check for input. So we can say if input.getKey. From here, you could say keycode dot, maybe A, or, if you're using WASD, or we could say input.getKey keycode.left arrow if you want to also use the arrow keys. Well, then we will move our transform position plus equals our direction times the speed, right? Just like we did for our invaders. So direction will be left times our speed. And then we're also going to times by delta time to account for frame rate. The important thing here is to use get key versus get key down. The difference there is get key is going to return true every single frame you're pressing that key down, whereas get key down will only return true the first frame you're pressing it down. And so if we want to be able to consistently move for as long as you're holding that down, then we should use get key. And we should do the opposite direction as well. So let's add get key keycode.d or input get key keycode.right arrow. I have a typo there. Keycode.right arrow. And in this case, we'll update our transform vector3.right times speed times time.delta time. And that should be it for player movement. Let's go ahead and test it out. Here we go. I'm pressing left and right, and I can move left and right. It's perfect. It's really simple, and we can always adjust that speed if we need to. Let's move right on to our laser now. So let's say when the player presses a different input, we will shoot our laser. So we can say if input get key, and in this case I'm going to use get key down because you should only have to press the button once to shoot, and then you have to press it again in order to shoot again. So get key down, keycode.space, and we can also do maybe our left click of our mouse button. So we can say get mouse button down, and we provide an index here which represents which mouse button. In this case 0 is our left click. And we can say, we can call some new function, maybe we call it shoot. Right, so when you press that input down, we will shoot. And inside here, we need to instantiate a new laser. And then from there, the laser will move. But we actually need an entirely different script to handle that. So let's create a new script. And I'm going to call this projectile. I'm specifically going to call it that and not laser, because we're going to reuse the same projectile script for both our lasers and for the missiles that invaders shoot. So in our projectile script, let's delete everything. And just like we've done for some of our other transforms, we're going to update its position based on direction and speed. So let's add variables for that, direction. And let's add a variable for speed. And in this case, we're making our direction a public variable because we want to be able to set that in our editor, because we're going to set the direction to be different for our lasers. It'll be up, and for our missiles, it'll be down. And same thing, speed will probably be different between those as well. Within our update function, we can just simply say this.transform.position plus equals this.direction times speed times delta time to account for frame rate. And that's really it for our projectile script. Now, if we go back to our player, inside our shoot function, we need to instantiate a new projectile. But we're going to need a prefab that contains that projectile script on it. So let's set that up, and we'll call this laser prefab. And we'll go ahead and set that up in the editor in a minute, but let's finish writing our script. So when we shoot, we will instantiate a new instance of our prefab. The position should be the position of where you're shooting from. So since this is the player that's shooting, we want to use our player's position initially. And rotation shouldn't really matter, so I should be able to just set this to identity, which is basically no rotation. And that's really it. We can test this out, but of course we'll need to set up our prefab. So let's create our laser prefab. If we go to our sprites, we can drag in our laser into our scene. So there's a little laser there. I'm going to make this green to match the player so the user knows it is the player's laser. And this is going to need a box collider 2D. Let's mark that as a trigger. The size gets set for us. That looks good. And then finally, we can drag this into our prefabs folder here. And now we have our laser. Let's go ahead and assign this to our player. Oh, let's delete it from our scene. Let's switch over to our player now. You can see the prefab property shows up here, and we can drag in our new prefab to that slot. Oh, it doesn't let us because it doesn't have a projectile script on us, and our prefab is expecting that script to be there. So let's go ahead and add our projectile script to our prefab. And for our laser, we want to set the direction. So in our case, the direction will be up, which is just simply a value of 1 in the y-axis. Let's say maybe our speed is maybe 30. We can play around with that. Let's go back to our player, and now we can drag this in. There we go. Let's run our game and see what happens. So I can shoot. Looks good. There's no collision detection yet, but that's okay. We'll worry about that soon. And that looks good. Now, one thing that is a problem is in Space Invaders, you're supposed to only be able to shoot one bullet at a time, or one laser at a time. So there should only be one laser active in the scene at a given time. So how can we go ahead and set that up? In our player script, we can create a new variable here that keeps track of whether our laser is active. So it'll be a Boolean, which will be a true or false, laser active. And so we only want to shoot if our laser is not active. So only instantiate a new laser prefab if our laser is currently not active. And from this point, after you do instantiate a laser, we want to set that to be true. Now the problem is we're never setting this back to false. So how can we determine when this object actually gets destroyed and then we can shoot a new one? So in our projectile, we can check for collision. So we can say on trigger enter 2D, collider 2D, and we'll call this other. So this is a function Unity is going to call for us automatically. Because we added a collider component to this object, this will get triggered for us. And so anytime the projectile collides with anything, we should just destroy the projectile. right away. So we can say destroy this.GameObject. And we might end up doing some additional logic in here later, but at the very minimum, we want to make sure when our projectile is destroyed, when our projectile collides with something, it gets destroyed. We also need to inform our player, though, that that projectile was destroyed. So we need some kind of callback or some way to inform the player that that happened. So what we could do is add an action here, which is specifically a C# thing. So this is using like C#'s delegate pattern. So we'll say, actually, this will be system.action. And let's say this is destroyed, right? That'll be the name of our callback. And so before we actually destroy our object, we will first call that callback. So we'll say this.destroyed invoke. And this is a way to allow other scripts to sort of register when some event happens. So you can think of this as an event. And then this is where we're actually invoking that event to say this event is happening right now. And so when we actually create our projectile, first we need to grab a reference to it. When we actually create our projectile here, we can subscribe to that event, essentially. That's one way you can think about it. So we can say projectile.destroyed, and we can add a function we want to call whenever this gets invoked. So let's say there's a function called laser destroyed. And we can say laser destroyed here. So we're saying we want this function to be called when this delegate gets invoked, and that delegate will get invoked when it collides with something. And then of course when the object will get destroyed as well. And so when the laser is destroyed, now we can set our Boolean back to false, which will then allow us to shoot again. Let's go ahead and test that out. We shoot. There we go. So I shot once and I can't shoot again. It's not letting me shoot again. You can see on the left here, our laser is still here. It actually hasn't been destroyed yet. And you can see its position is still moving. So it's still flying through space. We just don't see it anymore because it's way off the screen. So we might be wondering, why did it not actually... It's supposed to collide. In this case, it should have collided with, let's say this top boundary up here, right? In this case, it didn't. And that's because our object is missing a rigid body. In order for collisions to happen, Unity's physics engine will simulate all collisions. So to have those collisions happen, we need at least one of those objects to be a physics object. To make something a physics object, we need to add a rigid body to it. So we can add a rigid body 2D component to this. I'm going to drag it up here. Usually I like to have it, the order doesn't actually matter, but I like to have it rigid body, then the collider. And by simply adding this component, this object is now a physics object, which means physics will be simulated on this object, including collisions. Now the problem is we don't want the movement of this object to be simulated through the physics engine. We just simply want the collisions. So we can change the body type from dynamic to kinematic, and that'll collapse a bunch of those properties, those physics properties that we don't really care about. So this will allow collisions to still happen, but without actually simulating movement, because we're handling movement ourselves in our script. Let's go ahead and test this out one more time and see if it works this time. So you might have saw that it showed up and then it disappears right away. And that's because our laser is colliding with our player. So we don't want our laser to collide with the player. So how could we change that? Well, one way is we can use different layers here. And Unity provides a way to tell different layers if they can or can't collide with one another. So let's go ahead and add some new layers here. I'm gonna go to layer, add layer, and we'll add a layer for our player. Let's add a layer for our, I'm gonna add several here, even though we're really only care about the player and the laser. I'm gonna add all of them we're going to need for our entire project. So let's have player, invader. Let's also have laser, and let's have missile. So those are 4 layers. You can kind of imagine the player and the laser go together. So we're going to turn off collisions between those 2 layers. And we're going to also turn off collisions between our invaders and our missiles, because we don't want the missiles they shoot to collide with one another either. So now that we have those layers, we can actually set this on our laser. So that's set. Let's go to our player, and let's also set our layer on our player. Let's go to our invader base, and let's set the layer on that. So that's our base prefab. And we don't have the missiles yet, so we'll worry about that later. And then from here, if we go to edit, project settings, you should get a new window. I'm going to drag this over here on the side. We want to look for physics 2D. You can see at the very bottom is a collision matrix. So this is what's indicating what layers can collide with what other layers. So we want to turn off collision between our player and laser. We also want to turn off collision between our invader and missile. So now collisions cannot occur on objects that exist on both of those, or if the objects that are collide have those 2 layers set, they will not actually collide. The physics engine just completely ignores it. So you can see now I can properly shoot. It collides with the bunker, it collides with the enemies. And let's make sure that we can shoot beyond the edge of the screen. Well, not really. It should get caught by the border up there, that boundary we had created at the very beginning of our tutorial. And it does. You can see I shoot, the laser gets created, and then it gets destroyed once it hits that. So everything is working perfectly. Let's handle the collision between our lasers and our invaders, so we can actually kill the invaders when we shoot them. Let's go ahead and open up our invader script. And let's add that on trigger enter function we had added for our projectile. On trigger enter 2D. It takes in 1 parameter here, which is a collider 2D. We'll call that other. It's the other collider or game object you're colliding with. So we need to verify that this other object is indeed a laser. So one way we can do this is say if other.gameObject.layer. So if you remember, we had set the layer on our laser to be called layer. So we can actually just check that directly. We could say layer mask dot name to layer, and the name is laser. Right. And so this is a way of guaranteeing that the object we're colliding with is the laser. And when it is the laser, that means we need to be killed. This invader should be killed. So one of the first things we want to do is actually set this object to be deactivated. That way it disappears, it stops rendering, collisions stop happening on it. It's going to completely turn off this game object. And we also want to inform back to our invader scripts that this invader has been killed, because the invader script is going to keep track of the total amount of invaders that have been killed. The reason for this is, well, for one, so we can know when all the invaders have been killed and we can start a new round. And also in Space Invaders, the invader's speed is supposed to be dependent upon the number of invaders alive. So we'll use that variable to adjust our speed here. So how can we inform the invaders as a whole that this particular invader has been killed? Well, we can do the same thing we did for our projectile and our player, where we have this action here that gets invoked whenever something happens. So let's kind of set it up the same way. In our invader here, we'll add a new action. We'll say system.action, and we'll call this killed. And so when our laser collides with the game object, we will invoke that. This.killed.invoke. And now whoever registers with this delegate will know when the invader was killed. So our invaders, since this is the script that's actually instantiating our invader, we can go ahead and register our callback there. So we can say invader.killed plus equals some function we want to call whenever the invader is actually killed. So let's add that function. We can say we can just say invader killed, right? and we'll do something in there. But let's go ahead and finish this. Invader killed. Oops, invader killed. There we go. So once again, this function will be called anytime this delegate gets invoked, and that delegate will get invoked whenever our invader collides with the laser. So inside here, what should we do? Well, we want to keep track of how many have been killed in total. So let's add a variable for that. I'll actually make this, I'm going to make this half public, half private. I'm going to say invaders killed, or we'll just say amount killed. I'm going to make this public getter, but a private setter, because we might want to access this information from other scripts later on. And then we're going to also need to use this to calculate a percentage of how many invaders are still alive. And so to calculate a percentage, we just need to take this and divide it by the total amount of invaders. So we might want to have a property here that calculates the total invaders for us, and that's just going to be rows times columns. In this case, what I'm typing here is an equal sign followed by a right chevron, or like a greater than symbol. And this turns this into a computed property or calculated property. So we can just say this dot rows times this dot columns. And then we can have this similar thing. This should be a float actually, which is, you know, something like percent alive. Or it should be percent killed maybe. And this will say this dot amount killed divided by our total invaders. So if 100 of them have been killed and there's 100 total invaders, well, then that'll be 100 divided by 100, which is 1. Or in percentages are often expressed between 0 and 1. So 1 would actually indicate 100%. So 100% have been killed in that situation. So given these properties here, oh, there's one more problem. Because these are integers, when we divide two integers, it's just going to then round down to 0, right? So because this is supposed to be between 0 and 1, we need to make sure these are floats here. Otherwise, they're just going to get rounded down and we're not going to get the accurate value there. So let's just cast those to be floats, percent killed. Now we can factor this into our speed here, because speed should be determined by however many invaders have been killed. So instead of just having a flat value like this, we're going to change this. And we're going to use something called an animation curve. It'll make a lot more sense in the editor where we can visualize what this looks like, but it's basically just like an XY graph. So the x-axis of this graph indicates our percentage, and our y-axis indicates the speed you want. So let's say at a percentage of 0 being killed, maybe they move very slowly. And at a percentage of 100%, they'll move very fast, right? So let's get rid of that. Well, that'll just be speed. And here our speed becomes this dot speed dot evaluate based on the percentage killed. So when we evaluate our graph, we need to provide time. Obviously, it's called animation curve. So usually you use those in animation, and animation is, you know, dealing with time. But we don't have to use this specifically for animation. We can use them just for interpolation and stuff. So in this case, time you can think as our percentage. So speed evaluate based on how many have been killed, and that will give us the correct value. Now, of course, we need to set up that graph in our editor so we have the right, you know, we have values that make sense for our game. So let's go ahead and do that. Go to our invaders objects inspector. If you click on our new speed property here, you can see it brings up a graph, right? And I can choose one of these preset ones. You can have various graphs here. And so for us, we might want it so at time of 0 or at percentage 0, our value is really small. Our speed is really small, right? So when all of them are alive, so 0% have been killed, we want the speed to be very slow. And the more you kill, the faster they get, All right, so maybe add a percentage of 100 or 1. Maybe the speed here will be like 8. All right, let me close this and reopen it so it readjusts. And maybe I want to just change this a little bit here. I can change this curve a little bit more, so maybe it becomes more like this. It's like almost exponential in a sense. So it stays slow. It almost stays pretty slow all the way up until you have 50% of them killed. And then after 50%, it starts getting faster, like a lot faster compared to that first 50%. But of course, you can completely adjust this however you desire. And this is one way you can change the difficulty of your game. Let's go ahead and test this out and see if everything's working. So for one, we should be able to shoot. They disappear. Great. And we should be able to know, or we should be able to indicate or see that these are becoming faster the more we kill. So let's go ahead and kill a bunch of these invaders. And hopefully they get faster and faster the more that are killed. Should start to get a little faster now, and of course I could always adjust that curve if I wanted to. It doesn't seem like it's getting any faster, so we might need to look at our code there. Definitely does not seem to be changing. Oh, that's because we never went back to our function here and did anything. So we forgot to implement that. So when Invader is killed, when that function gets called, we need to increment our variable here, amount killed. So all we need to say, this dot amount killed plus plus. That's it. And that should solve our problem there. Just for the sake of testing, I'm going to change this. So we can even change it while it's running. Let's say initially it has a value of 4. So they're a lot faster now. All right. I can even set this back maybe to 1. But we should see this, we should definitely see this get faster now as we kill these invaders. Or like if I set this to be almost 0, or what we had it originally, 0.25. So that's 0.25. Let's say maybe at, you know, if we adjust this, yeah, so you can see how the speed is changing depending on how many are actually alive. So that seems to be working. We can, of course, adjust this to get it to our desired effect. I might adjust it a little bit, but overall, that looks good. Let's handle the missile attacks from our invaders now. Open up that script again. And what we're going to want to do is perform a function every X amount of seconds that will have a chance to spawn missiles. So let's go ahead and add our start function here, where we can invoke repeating some function that will happen every X amount of seconds. So we need a function that we can invoke. Let's add a new one called missile attack. So the name of that function there. And then we need to invoke this every X amount of seconds. So let's have a variable for that. And we can say, call this missile attack rate. So how often will there be missiles? This dot missile attack rate, this dot missile attack rate. Okay, so we will call our missile attack every X amount of seconds on repeat. Oh, and let's say this has an initial value of 1 second, maybe. That should probably be fine. So in here, we want a chance to spawn a missile from each and every invader that is alive. Now, if all of our invaders are alive, we want that chance to be pretty low. If the chance was high, well then, you know, all 55 invaders would spawn a missile at the same time, and that would not be good gameplay. So it should be sort of an inverse relationship there, where the more that are alive, the smaller chance there is to spawn a missile. Let's go ahead and set up our basic for loop where we can loop over each of the invaders. The exact same thing we did in our update function. So I'll go ahead and just copy that. I'm also going to copy this first if statement, which is checking if the invader is currently active. If the invader's not active, well, that means they were killed. If you remember, we had set that invader to not be active whenever they get killed. So if the invader's not alive, they skip over that one. And then from here, we can check to see if they should actually spawn a missile. And this will be a random chance. So we can say random.value, which generates a value between 0 and 1. You can think of that as a percentage. And if that is less than some chance percentage here, well, then we can spawn our missile. So we want to say 1 divided by the amount of the amount that have been, or the amount that are alive, actually. So we don't have a variable for that. Let's go ahead and add that. Amount alive will actually be this dot total invaders minus however many have been killed. And let's go ahead and use that variable, amount alive. So let me explain what's happening here. So let's say there are 55 invaders alive, which would be all of them. It's going to be 1 divided by 55, which is going to be a really small number. So the chance that this value here is going to be less than that really small number is going to be very, very low. And so it might occur for 1 of those 55. And that's actually what this is saying. This is saying 1 out of 55 of those would likely spawn a missile, which is appropriate. Now, as more and more die, that chance is going to get lower and lower, or higher and higher, I guess you could say, depending on how you look at it. And so it should balance out over time, even as you kill different invaders. So in here is where we can actually spawn our missile, but we don't have that yet. So let's go ahead and add a prefab for our missile. We'll say, and this will be a projectile. So if you remember earlier, I mentioned we're going to use that same projectile script we use for our laser as well as for our missiles. So we'll call this missile prefab. It's a projectile. Using that prefab, we can instantiate it, an instance of it or a copy of it. And the position here should be the position of our invader. So we can say invader.position. And then the rotation shouldn't matter, so we can just set that to identity. And when this happens, I want to guarantee that only 1 missile can be active at a time. So I'm going to break out as soon as we spawn one. As soon as we spawn one, we won't try to spawn any more for this attack. So it kind of guarantees only 1 missile can be shot at once. But remember, this is going to be repeated, every second or however often we set that to. So it's still there's still gonna be plenty of missiles happening. Let's go ahead and set up our prefab and our scene. It's pretty much gonna be the same as our laser here. But let's go ahead and use our missile sprite. There's our sprite render. Let's add those same components as our laser. So rigid body 2D. We want to change this to be kinematic. That way we have collisions, but we aren't simulating the movement. Let's add our box collider 2D. Set that to be a trigger. And let's add our projectile script. We're going to change the direction to be down, which would be -1 in the Y axis. And let's say the speed is maybe 20. It'll be a little bit slower than the lasers. I believe we set the lasers to 30. So given this object here, oh, and also we can set the layer. We had added that previously, so let's go ahead and do that. Given this game object, now we can drag it into our prefabs folder, and now we have our missile prefab. We can delete it from our scene now, go back to our invader script, and we can assign that reference there. And let's go ahead and try it out. So there's one, boom. Now we got an error there, so there's some kind of error happening, but something, overall looks like it's working. Let's go ahead and debug what this error is. So projectile, so it's saying this destroyed callback is null. It's not being set, and so when we try to invoke it, it causes an error. That's because we're only using this destroyed for our player. We're not using it for our invader. So all we can do is just add a simple check here to make sure that our callback is not null, and then we can invoke it. Otherwise, if it is null, or in other words, if no one's actually using this, then we won't invoke it, and it won't cause that error either. Let's go ahead and test that again. And there we go, it looks good. And let's make sure collision is happening. Yeah, so it's colliding now properly. It collides with me. Of course, we don't have any logic yet to kill the player, but we'll get to that. And there we go. So there is our missile attacks. At this point, we have an almost fully playable game of Space Invaders. There's just a couple things we need to do to tie it all together. So for the sake of time, I'm not going to do a full game state for this tutorial. So I'm not going to do scoring and lives and game over and UI and all of that, because it would probably add another hour onto the length of this video. So I'm going to show you one very simple way we can kind of reset the entire game, you know, under certain conditions, such as when the player wins or kills all the invaders, or when the player dies. We can just reset the entire game with pretty much one line of code. So let's go ahead and take a look at how to do that. So in our invader script, in our callback of where an invader gets killed, we can check to see how many invaders have been killed overall. So we can check if all of them have been killed. So if this set amount killed is greater than total invaders, well, that means you've killed them all, and we can consider that a win condition. Now, normally speaking, you might just move on to the next round and it would kind of restart, but you would maintain your score and stuff like that. Because we're not going to do score in this tutorial, we're just going to reset the entire game. And all we need to do this is one line of code. But first we need to import something. So we need to import Unity engine.scene management. And this is going to allow us to just reload our scene. And when we reload our scene, everything will be back to their initial states. So we can say scene manager.load scene. And then we can say scene manager.get active scene. And then we need to load it by the name of it. So we'll say .name. And that's it. So as soon as all of the invaders have been killed, we will just reload our entire scene, which is like the simplest way you can restart your game. Now, once again, if you're going to handle additional things like scoring and stuff, then you might not want to do this. But for simplicity, this is the easiest way to do it. Now, we're going to want pretty much the same thing when our player dies. And so our player can die in a couple of different ways. Let's go ahead and add some collision detection for that. On trigger, enter 2D, collision 2D, other. And so when the player collides with either a missile or the player collides with the invaders themselves, that will be considered a lose condition. So we can check both of those. If other.gameObject.layer equals layer mask name to layer invader, or other.gameObject.layer equals layer mask name to layer missile, well, then we will also consider that a game over, and we'll just restart the game in the same way we did here. So I can actually just copy that line of code, paste that in. Let me import scene management, and there we go. So once again, just a very simple way of resetting our entire game. Let's go ahead and also, let me make sure this is correct. Collision, this is wrong. This was supposed to be collider 2D, not collision 2D. Collider 2D, my mistake. The only other thing we have missing is the collision between the invaders and the bunkers. All right, so when the invaders get farther enough down, they should actually destroy the bunkers entirely. So let's go ahead and add a script for bunker. For our bunkers, select all 4 of our bunkers and drag this script onto it. And here we can check for collision between the bunker and the invader. So we can say, once again, on trigger enter 2D, collider 2D, other, If other.gameObject.layer equals layer mask named layer invader, well, then we can destroy our bunker. And by destroy, I'm just going to turn it off. We could fully destroy it since we're just restarting our scene. However, if you end up refactoring this to add scoring and other things like that, new rounds, you probably don't want to destroy the bunkers entirely. You probably just want to turn them off and then turn them back on whenever you reset. But yeah, so that should be good. And let's go ahead and test out these different things we've just added. So for one, let's test out when I get hit by a missile. And for the collision to happen, we gotta make sure we have a rigid body on our missile, which we do at the moment. So just double check that you do have a rigid body. Make sure it's set to be kinematic. And that'll at least allow us to detect collisions between our game objects. Let's try to get, I just need to get lucky here and get a missile to fall. Oh, I shouldn't have moved. There we go. So look, so I got hit, everything reset. The invaders I'd killed are back to normal. We're all good there. Let's test a couple other conditions. I'm going to, just for the sake of testing, increase the speed here. I want to see when they get all the way to the bottom and they eventually touch me, I should also die and lose, and the game should reset. They'll also destroy the bunkers. That's working correctly. Good. And they touched me and the game resets. So there we go. And the other condition is when I kill all the invaders, the game should reset. Now, once again, for the sake of testing, I'm just going to set the number of... I'm just going to change the number of rows and columns. Let's say there's one row and there is, 5 columns. And I can just quickly destroy all of these. More here. One, and oh, I hit the missile on that guy. Let's wait till he comes back. I missed again. I missed it. There we go. Got it. So boom, I kill all the invaders, the game restarts. And so there, everything is working correctly. Let me reset these back. So 5 rows, 11 columns by default. Now you might be wondering about this mystery ship that's been sitting up there the entire tutorial and we have yet to touch it. I'm actually going to leave this for you to try to implement yourself. So challenge you to see how you can implement this mystery ship. The normal logic of this is that it goes back and forth from right to left and left to right, so on, every maybe 30 seconds or so. You could actually implement it in different ways. I'm not entirely sure what the exact logic is of the original Space Invaders game, but I ended up implementing this separately, and what I did is basically every 30 seconds the ship will appear and it will move. It'll just move across the screen, and if you do happen to kill that ship, you will get extra points compared to the invaders. So that's the challenge for you to see how you can implement that on your own. If you're having trouble with that, I do have the source code for all of this available on GitHub, the entire project. And that project contains, everything. It contains scoring, lives, the mystery ship. It contains the bunker destruction physics. So like when you shoot a bunker, it starts to crumble apart and destroy. I really wanted to do that for this tutorial. However, it's pretty advanced compared to the rest of the tutorial, so I don't feel like it's appropriate to do here, and it's complicated enough that's going to eat up a lot of time. So once again, all of that stuff is available in the full source code for this game. There's a link in the description of the video to GitHub where you can have all of that if you deem, but also challenge you to see how you can implement some of this stuff on your own as well. I appreciate you taking the time to learn how to make Space Invaders with me. If you feel like you learned something, then give the video a like to let me know I did a good job. I know we did not cover absolutely everything in this video, but I highly encourage you to take what you learned and see what else you can implement on your own. If you get stuck at any point, you can download the entire project and source code on GitHub. The full project includes scoring, lives, game over, new game, user interface, and even the advanced bunker destruction physics. You can also join our community Discord server to ask for additional help directly from me and others. Finally, if you really want to support my work, consider joining me on Patreon to receive a number of exclusive benefits relating to my Unity assets, tutorials, and my upcoming game. Links to everything in the description of the video. Thank you for watching.